Hello, folks. My name is Leah Bonasaki from the Master Lab Systems. So today we'll be looking at Master the Microservices, a step-by-step guide. So let's look at the first slide. What are microservices? Microservices architecture breaks an application into smaller independent services. So each service handles a specific business function and it communicates via APIs. However, we'll be looking at that later on how microservices communicates to each other. So for example, if you have an e-commerce system, imagine you have a user service whereby it serves its own purposes, including managing of all the users using the system. Look, have also an order service that deals with managing all the order business related requirements. Also, we have a payment services which deals with managing the payments and requests to the services. So those are all interconnected services that serves as a microservices abroad. So that's how we develop these microservices systems. We'll split each service to its own separate component. Moving next. So what are the advantages of these microservices? So a microservice architecture gives an ability to scale for scalability. So imagine a scalability, it creates independent scale services. Flexibility, using a different technology for each services. Resilience, failure in one service doesn't break the whole system, and also it results in a faster deployment. So for example, scaling those services, if we have a busy services that we need to give it more resources, it becomes easier for allocating such resources for a service that has too much traffic. Also, the flexibility, in terms of the flexibility, we can have this project that has built with different languages, for example. So imagine an e-commerce systems that contains an order services built in a different language such as Spring Boot, for example, and also a user management service which is built in Python or other language depending. So it gives us that flexibility to use different technologies for each services. So the resilience, so meaning if one service is failing, the other service keeps on functioning. That's their role in microservices because that's how they work. So instead of having the whole system to crash down, at least other services they continue to work, to function, and to serve their business purposes. So in terms of faster deployment, because of we don't really have too much configurations due to each services being deployed separately, so it makes that thing faster deployment. Also, it makes it easier to even do some rollbacks as there isn't too much configuration done as the services are being splitted. Moving on. So how these services communicate? So communication between microservices happens in three ways. So we have a REST APIs, which is mostly used in the environments or in the corporate workspaces. Yeah, it's mostly preferred as it is very easy, which is the REST API calls. So services communicate via HTTP requests using the REST API calls. So for FAIN client, which is a declarative HTTP client methodology, so that way they communicate via declarative HTTP way. And also, so for message queues, so in message queuing, they use something called asynchronous communication, whereby a service will have to wait, and there's a wait, and then there's a wait, and then there's a sync. So meaning that one, each service has to wait until the first request has been processed. So that's how they work. Also, they are using a declarative process, the declarative HTTP way. Yeah. So moving on. So for now, let's look at setting up a Spring Boot microservice. So first of all, we'd require a Java service. Of course, well, you need to install Java and also use depending on what IDE you are using. Of course, if you are using IntelliJ, you can easily just spin it up on IntelliJ, or using the Spring Initializer, which is the web interface, to create a Spring project. So you set up that Spring project, add the Spring Web, which is some basic dependencies, and also we'll look at into developing the REST API. So building a simple microservice. So, for example, in a Spring Boot project, how we develop is a REST service while a microservice. So, how we define it also. So, we have this thing called a REST controller, which defines the REST API, how this communication will be made using the HTTP requests. So also the request mapping, meaning at hello. So that's how the request will come. Well, that's the first endpoint, meaning that's what the user will be using to interact with that system. So if, for example, on the browser, you can type when the system is up and running. If you type with the using the full URL and the hello, this is what you should be getting the hello from microservice. So also the get mapping, meaning you are defining this is the get request. So this simple endpoint or simple API, it's using a get endpoint, which is a get request. So you get that hello, and then that's what it returns, hello from microservice. Okay, folks, moving on. So let's look at the database microservice. So for each microservice has its own, normally it has its own database. So for example, if you had a user class, so this is how you would define its database attribute or its database entity. So depending on how many services you are having for that system. So that's the end of this session, folks. Well, for creating a microservice Spring Boot. So I will be, let's look at another microservice example that we can have. So in this project, folks, I have another microservice project that it's built with different tooling. So let's look at this one, for example. We have the Valley front end, which is a Node project. Well, it's a React project for front end, and also there is a Valley project, which is this one. It serves as the backend service for that front end. So this one, it only contains one endpoint for this project. So let's look at that endpoint, how it happens. So for example, if we look at this index, so this project, this is how it gets the data. So this is how it communicates to the REST backend project, which is this one. So once you start this project, this is how they should use the communication. So meaning on this port, this is how you are passing the parameter. So meaning if the backend save, which is this one, if it's not working, if it's down, for example, the front end will keep on functioning. However, only the save is coming, or only the endpoint coming into the project, which is the backend project, will not function, as it will be down for some reason. So folks, I think I need to end here. So if you like this video, please subscribe and like my channel. Also, if you have any comment, please post them to the comment section down. Yes, folks, I will be answering those. Thank you so much. Peace out.